X-intercepts, vertical asymptotes, and hosts of rational functions. Case 1. No cancelled factors. The factors of the numerator will give the x-intercepts, and the factors of the denominator will give the vertical asymptotes. Take note that if there's no cancelled factors, then the graph of a rational function has no holes.
So in this case, we're going to solve for the x-intercepts and vertical asymptotes only. Example 1. Both the numerator and the denominator are linear. To solve for the x-intercept, just equate the numerator to 0, then solve for x. X minus 7 is equal to 0. Transpose negative 7, we have x is equal to 7. The x-intercept is 7, 0. To solve for the vertical asymptote, just equate the denominator to 0, then solve for x. 3x plus 6 is equal to 0. Transpose positive 6, we have 3x is equal to negative 6. Divide both sides by 3, we have x is equal to negative 2. The vertical asymptote is x is equal to negative 2. Example 2. This time, the numerator and the denominator are both quadratic. The first attempt that you're going to do when dealing with quadratic expression is to factor it. The factored form of the numerator is x plus 6 times x minus 4. And the factored form of the denominator is x minus 3 times x minus 2. To solve for the x-intercepts, equate each factor of the numerator to 0, then solve for x. First, we have x plus 6. X plus 6 is equal to 0. Transpose positive 6, we have x is equal to negative 6. Next, we have x minus 4. X minus 4 is equal to 0. Transpose negative 4, we have x is equal to 4. The two x-intercepts are negative 6, 0 and 4, 0. To solve for the vertical asymptotes, equate each factor of the denominator to 0, then solve for x. First, we have x minus 3. X minus 3 is equal to 0. Transpose negative 3, we have x is equal to 3. Next, we have x minus 2. X minus 2 is equal to 0. Transpose negative 2, we have x is equal to 2. The two vertical asymptotes are x is equal to 3 and x is equal to 2. Example 3. The factored form of the numerator is x times x minus 8, and the factored form of the denominator is 2x minus 1 times x plus 4. For the x-intercepts, we have x is equal to 0, and x minus 8. X minus 8 is equal to 0. Transpose negative 8, we have x is equal to 8. The x-intercepts are 0, 0, or origin, and 8, 0. For the vertical asymptotes, we have 2x minus 1. 2x minus 1 is equal to 0. Transpose negative 1, we have 2x is equal to 1. Divide both sides by 2, we have x is equal to 1/2. And x plus 4. X plus 4 is equal to 0. Transpose positive 4, we have x is equal to negative 4. The vertical asymptotes are x is equal to 1/2 and x is equal to negative 4. Example 4. The factored form of the numerator is x plus 3 times x plus 3. Since the factors of the numerator are identical, we only have one x-intercept. X plus 3 is equal to 0. Transpose positive 3, we have x is equal to negative 3. The x-intercept is negative 3, 0. For the vertical asymptote, we equate 3x to 0. Divide both sides by 3, we have x is equal to 0. The vertical asymptote is x is equal to 0 or y-axis.
Example 5. The factored form of the numerator is x plus 9 times x minus 9, and the factored form of the denominator is 2x minus 3 times 2x minus 3. For the x-intercept, we have x plus 9 is equal to 0. Transpose positive 9, we have x is equal to negative 9. And x minus 9 is equal to 0. Transpose negative 9, we have x is equal to 9. The x-intercepts are negative 9, 0 and 9, 0. Since the factors of the denominator are identical, we only have one vertical asymptote. 2x minus 3 is equal to 0. Transpose negative 3, we have 2x is equal to 3. Divide both sides by 2, we have x is equal to 3/2. The vertical asymptote is x is equal to 3/2. Case 2 with cancelled factors. If a cancelled factor is different from any of the remaining factors, then the remaining factors of the numerator will give the x-intercepts, and the remaining factors of the denominator will give the vertical asymptotes.
The cancelled factors will give the wholes. However, if a cancelled factor is identical from any of the remaining factors, we have two cases. First, if the cancelled factor is identical to the remaining factor of the numerator, then the said factor will give the whole. Second, if the cancelled factor is identical to the remaining factor of the denominator, then the said factor will give the vertical asymptote. Example 6. The factored form of the numerator is x plus 7 times x minus 1, and the factored form of the denominator is x minus 1 times x minus 5. The cancelled factor is x minus 1. Notice that the cancelled factor is not identical to any of the remaining factors, x plus 7 and x minus 5. For the x-intercept, we just equate the remaining factor of the numerator to 0, then solve for x. X plus 7 is equal to 0. Transpose positive 7, we have x is equal to negative 7. The x-intercept is negative 7, 0. For the vertical asymptote, we just equate the remaining factor of the denominator to 0, then solve for x. X minus 5 is equal to 0. Transpose negative 5, we have x is equal to 5. The vertical asymptote is x is equal to 5. For the whole, we just equate the cancelled factor to 0, then solve for x. X minus 1 is equal to 0. Transpose negative 1, we have x is equal to 1. This means that there is a whole at x is equal to 1. To determine the coordinate of the whole, we just substitute x is equal to 1 into the simplified form of the function. The simplified form of the function can be obtained by eliminating the cancelled factor. In this example, the simplified form of the function is f of x is equal to x plus 7 all over x minus 5. When x is equal to 1, we have f of 1 is equal to 1 plus 7 all over 1 minus 5, which gives 8 over negative 4, which can be simplified to negative 2. So the coordinate of the whole is 1, negative 2. Example 7. The factored form of the numerator is 3x plus 2 times x plus 2, and the factored form of the denominator is x minus 2 times x plus 2. The cancelled factor is x plus 2. Notice that the cancelled factor is not identical to the remaining factors 3x plus 2 and x minus 2. For the x-intercept, we have 3x plus 2 is equal to 0. Transpose positive 2, we have 3x is equal to negative 2. Divide both sides by 3, we have x is equal to negative 2/3. The x-intercept is negative 2/3, 0. For the vertical asymptote, we have x minus 2 is equal to 0. Transpose negative 2, we have x is equal to 2. The vertical asymptote is x is equal to 2. For the whole, we have x plus 2 is equal to 0. Transpose positive 2, we have x is equal to negative 2. This means that the graph of the rational function has a whole at x is equal to negative 2. The simplified form of the function is f of x is equal to 3x plus 2 all over x minus 2. When x is equal to negative 2, f of negative 2 is equal to 3 times negative 2 plus 2 all over negative 2 minus 2, which gives negative 4 over negative 4, which is equal to 1. So the coordinate of the whole is negative 2, 1. Example 8. The factored form of the numerator is x plus 6 times x minus 10, and the factored form of the denominator is x plus 6 times x plus 6. The cancelled factor is x plus 6. Notice that the cancelled factor is still present in the denominator. Since the cancelled factor is identical to the remaining factor of the denominator, x plus 6 will give the vertical asymptote. Let's solve for the vertical asymptote first. X plus 6 is equal to 0. Transpose positive 6, we have x is equal to negative 6. The vertical asymptote is x is equal to negative 6. For the whole, since x plus 6 will give the vertical asymptote, we can say that the graph of the rational function has no whole. For the x-intercept, we have x minus 10 is equal to 0. Transpose negative 10, we have x is equal to 10. The x-intercept is 10, 0. Example 9. The factored form of the numerator is x minus 5 times x minus 5, and the factored form of the denominator is x minus 5 times 2x plus 1. The cancelled factor is x minus 5. Notice that the cancelled factor is still present in the numerator.
Since the constant factor is identical to the remaining factor of the numerator, x minus 5 will give the whole. Let's solve for the whole first. X minus 5 is equal to 0. Transpose negative 5, we have x is equal to 5. So there is a whole at x is equal to 5. The simplified form of the function is f of x is equal to x minus 5 all over 2x plus 1. When x is equal to 5, we have f of 5 is equal to 5 minus 5 all over 2 times 5 plus 1, which gives 0 over 11, which is equivalent to 0. So the coordinate of the whole is 5, 0. For the vertical asymptote, we have 2x plus 1 is equal to 0. Transpose positive 1, we have 2x is equal to negative 1. Divide both sides by 2, we have x is equal to negative 1 half. The vertical asymptote is x is equal to negative 1 half. For the x-intercepts, since x minus 5 will give the whole, we can say that the rational function has no x-intercept. Example 10. For the numerator, factor out the GCF first, which is 2x. 2x times the quantity x squared minus 16. X squared minus 16 can still be factored into x plus 4 times x minus 4. The factored form of the denominator is x times x minus 4. The cancelled factors are x and x minus 4. Notice that the cancelled factors are not identical to the remaining factor x plus 4. For the x-intercept, we have x plus 4 is equal to 0. Transpose positive 4, we have x is equal to negative 4. The x-intercept is negative 4, 0. For the vertical asymptote, since there is no factor left in the denominator, therefore the graph has no vertical asymptote. Since there are two cancelled factors, we have two wholes. First, we have x. X is equal to 0. And x minus 4. X minus 4 is equal to 0. Transpose negative 4, we have x is equal to 4. The graph of the rational function has wholes at x is equal to 0 and x is equal to 4. The simplified form of the function is f of x is equal to 2 times the quantity x plus 4. When x is equal to 0, f of 0 is equal to 2 times the quantity 0 plus 4, which is equal to 8. When x is equal to 4, f of 4 is equal to 2 times the quantity 4 plus 4, which is equal to 16. The coordinates of the wholes are 0, 8, and 4, 16.